Hey everyone, I know it's been a while. This is the busiest season for us. This time of year when it can hit triple digits for several weeks in a row. Videos are going to be a little slower coming out. But today I've noticed on some of my wiring videos that people were still asking me colors of wires. And I can't emphasize this enough. The colors on wires aren't what you're looking for. What you need to know is how it's connected. So this is going to obviously be for people that, can see the wiring on their old motors. And if you get a new universal motor, I'm going to show you what those mean and how to wire them just like your OEM motor. So let's break it down, let's make it simple and understand how this works. So we can stare at papers and charts all day. We can look at these all day, but what does this mean and how do you translate it into wiring? Well, each one of these is showing you here's our motor. And each one of these is telling you exactly how to wire it. So between these colors on this particular motor, it's saying orange is going to be 120, black is going to be 120, and the blue is going to be your start winding, which is on your capacitor. Now, there are several different ways you can do this because of the nature of how a condenser motor works. It just needs power and power, and then the start winding. Simple thing here that you'll notice is that the capacitor wire comes off here. This symbol right here is the symbol for capacitance. So here on our drawing is these two brackets, which simply means this is the line that's going to be on the same capacitor together. So between just these two wires, if you see the word cap or you see this symbol for capacitance, you know that this blue wire that comes off of the motor is your start, and then your C, your common, your one leg of 120 is going to be what hooks up with that blue wire. So these are going to be together. The reason behind why we're only putting this with your common is where your windings go. So just remember, we're going to go with the wire that is on your C on your capacitor, standing again for common. So your common and your start winding should always be on your capacitor because it can be extremely unnerving to look at a universal motor and look at this and go, whoa, the universal motor looks way more complicated. So let's look at our 3-wire setup for our dual run capacitor, which I'll show you in a moment. And then our 4-wire setup if you have a smaller fan capacitor with only 2 poles. So here's a universal condenser motor. Remember first and foremost before we get into this to match all of the specs on your motor. So make sure that your motor, say with this one, it's a 208, 230, 1075 RPM, which if you watched my other video on what the RPM means on full load amps versus what it actually says on the motor, I get into all of that on the other videos. So you can go check those out if you'd like. That way you understand what that actually translates to. But just know that if it says 1075, it's the same thing as 1100 RPM, 1050 RPM, or 1200 RPM. All the same. So as you can see on our original motor, and sometimes when we get this close, it can get a little fuzzy, but yeah, I'll call it out for you. On your original motor, you can see it is a quarter horse, 208, 230, 1100 RPM. It also will tell you, most will tell you the rotation and what size capacitor you would need. So just make sure as you pick, and this one's a little fuzzier here. See if I can't move out just a tiny bit. Well, in any case, those specs will be right here. This is a multi-horsepower motor, and it goes from a third to a sixth. When it says to a sixth, by the way, I recommend only going up to a fifth, because technically this is going to lean more towards the third side and quarter horsepower. But you can use this for the quarter horsepower 1100 RPM motor. Now see here how it says 1075 and the other one says 1100. That's perfectly fine. Obviously you can see this is a little bit different than the OEM. And remember, at any time you can pause this if you need to. I'm going to not try to speed through it. That way you can kind of go through at your own pace or rewind and slow it down. But this is our original. So keep in mind, like we mentioned before, the line that comes off of your S on the motor, that's going to be your start winding, or your one leg of your capacitor. The C, whatever color that might be, is going to be your one leg of 120. And your R, which is the one that goes back to your contactor, is going to be your other leg of 120. So now we're going to take the knowledge we know and we're going to apply it to the universal. And we're going to do this one of two ways. Let's first start off with the 3-wire. All right, here I've got this for you guys. And again, keep in mind, color does not matter. I have so many of you messaging me on the other videos, I have a red wire, I have an orange wire, I have a yellow wire. Wire color doesn't matter, because what we're doing is we need to know what these mean. Most universal wiring diagrams are going to look like this. It looks pretty scary, right? But look here, so on our motor, it tells us the white wire, this one right here, is going to be our one leg of 120. The black wire is going to be our other leg of 120. So again, just make sure when it says these two, in between them it has either a line or arrows, something like that. That's going to be your high voltage. So power, power. Okay, these right here on universal motors, what they are telling you is what the motor defaults to. For example, it's telling us on this one, and this one does have a key for you, so keep that in mind. It should label it. What these do is they change the rotation of your motor. That way, since it is universal, you can change it to whatever rotation you need to simply by changing the wires. On this one, it gives you a handy little note here that says to reverse rotation, interchange orange and yellow leads. So we find our orange and yellow or whatever other color wires yours are. Some of these have like an insulated plug, big thick rubber plug that'll have like a multicolored wires, or it will have like a white and a black. And those you just pull the plug apart, you twist them, and then you put them back together, and that will reverse your rotation. This particular style, that's what these wires are for. So since this one defaults to counterclockwise lead end, which means if you're looking at the motor this way, that's the rotation it's going to be. So this one is saying it's going to be counterclockwise lead end, so looking from this side of the motor. Now remember, easy fix for this is if you get a little confused about, which one you need, just put everything together, plug it up, and if the air isn't coming out of the unit, then these need to be swapped. So these, again, in between all this, which looks like a bunch of jumbled nonsense, that's what these mean. So now that we know what this is telling us, now we look at this. Now, this can get a bit confusing if you're doing a 3-wire setup. So I'm going to break down what this means because there's no simplistic way to put this. The brown and white stripe, this one is filling the same function as the white wire. So the white wire on this motor, yours could be yellow, purple, orange, etc. On this particular motor, the white wire is the same as the brown and white stripe. These are on the same exact winding, which means if you're going with a 3-wire setup, just like the original motor, you don't need that brown and white stripe anymore. So when doing a 3-wire setup, you're not going to use this wire. By process of elimination, we now know that that brown and white stripe, since we're not using it, we know that this wire and this wire is the same. And I'm talking about the brown and white, not the solid brown. We now know that that capacitance symbol is telling us that the solid brown is our start, which is going to go on our dual capacitor, which we now know that the start is going to go on the fan on our capacitor. And since we know this is going to go on the fan, the other side of that capacitance, see how this wire is the same as this wire? So process of elimination, we know that the brown is going to go on the S, and the white is that, see that? The other side of that capacitance, which is where this is branching off. Remember what we said before? Now we know the white on the capacitor is going to be our common. That's the breakdown of what these universal motors mean when you see all of this. On this motor, again, it could be yellow, orange, purple, etc. Goes on the C, and our start winding for the fan motor, the other side of that capacitance, is the fan. So keeping that in mind, all of this, the only thing you need to know about that is that it changes the rotation and what it defaults to. Now, on most of these motors, somewhere on the label, you're going to see something that says 10 MFB, the symbol UF, or you're going to see cap. This is telling you what the universal motor needs. So make sure if your other motor took, say, a size 7.5 or a 5 with one of these next to it, you know you need to change that capacitor to match. So make sure you pay attention to that. Now, I have a lot of people in store ask me why their universal motor has a green and yellow striped wire, which is the most common universal color code for ground. When your motor directly attaches up against your lid or your grill on your motor and is hanging upside down, you do not need a ground wire because your unit is grounded and your motor is attached to your unit, meaning you don't need a ground wire. Now, if you have a different type of setup on your motor, say for example, some people have a motor where the shaft is facing up toward the lid and then a band that comes around it like this, those motors absolutely need a ground wire. So make sure you keep those on there. Keep in mind, know about wire colors. Stop worrying about the color of the wire. What we're doing here is we're learning what those diagrams mean. Now, some of you might have something like a Heil. I've seen some Yorks that do it as well. They have a weird diagram. And for that, I tell you to go on YouTube, or I might make a video here in a little while explaining to you what those mean. Stop caring about wire colors, okay? This is the purpose of this video, is I am showing you exactly what these mean. That way, you know, no matter what wire color you're using, you know where they go, and you're not having to freak out because you now know what these diagrams mean. One more thing to cover is the black. And for most motors, the black is going to be your run. Now, not all, again, so pay attention to that. The run on your motor will go back to the other leg of power on your contactor. All right, guys, we are here at Mikasa. Sometimes it can be a bit hard to film up at work. It's a busy time of year, so sometimes we'll have people walk up and knock on the doors and all kinds of stuff. So this is just kind of letting you know what our common start and run is. So we've covered common, we've covered start, and now let's talk a little bit about run. Now again, these wiring diagrams, and this would be for an OEM motor or something similar, these are going to represent your common start run. So between these two, it's telling you these are your lines, so we're reviewing a bit. You're not going to be looking at these videos trying to learn a lot. It's just you're trying to figure out how to put in your new motor, right? Run is just, on a separate winding from your common, but they're both going to be power. Now, your start winding for your motor, more often than not, I see brown. Again, do not look at colors. Remember how we know this is going to be our common is it will have that line. Sometimes it'll be arrows. I've even seen squiggly lines. But in any case, we know the one that's branching off one of the main power legs is going to be our start winding for our motor. The start winding is different in how it plays its role for your motor. Again, just for simplicity's sake, make sure that you have whatever color wire it is right here. Again, it can be brown. I've seen purple. I've seen blue. Just to make sure that one, or any of these colors, or it could be a different color wire, is the one that goes between the capacitance on your 120, your common on your capacitor. Now, once we know this, we know that whatever color this one is going to be, whether yours is white, I've seen yellow, I've seen orange, I've even seen red. Again, it could be purple with red polka dots. Between these two, on our start, when we're looking at a dual run capacitor, on your dual run capacitor, you're going to have 3 poles. The one that says Herm, which we've gone over before in other videos, is your compressor wire. That has nothing to do with your fan motor. So for your fan motor, we're focusing on these two, which one will be labeled C for common, And this one is going to be labeled fan. All right, so compressor. We're not going to worry about that on our motor, right? So C, we know that whatever color wire this is, it's going in between the start here, or the start's going to branch off. And sometimes, as I mentioned, there can be a little line like this coming off of it with the symbol, and that can say cap. That's going to go on your fan terminal on your dual run capacitor. The one that goes between your run and your common on your motor, which is, again, the one that's going to be by itself, will be your run. So whatever color you have here, guys, that's going to be the one that goes on your C. On the C, you'll notice you'll either have 1 or 2 more wires on here. Since you know on your C, that has to be 120 volts on there, you should have a jumper wire on that terminal. And that jumper is going to be going back to your contactor. Whether you have a single pole contactor or you have a double pole contactor, then that's where that's going to be going. The terminal on the capacitor that has usually 2 wires on it, and then you should have 1 and 1, that one that's jumping back to the contactor, that's going to be your common. As your machine turns on, your AC unit outside, your thermostat calls for the cooling, it's going to come out to your contactor, and on either side of your contactor, some of you have some that go on both sides, but there are these wires that are coming to your contactor here that has the low side voltage coming in from your thermostat. That's going to engage, pull in your contactor, which lets that 240 volts through. So obviously we know here is your one leg of 120. The other leg of 120 has to be on the other side of the contactor, which is where your run goes on your motor. Again, I've seen different colors, but the most common color I see is black. So since we know the run is simply your other leg of 120, and it's by itself, it doesn't go between the start winding or the fan on our capacitor, and it doesn't have the C connected to it without the words line between them. This one has to go back to power. Now, the run always goes on the opposite leg of the contactor. So if whatever color wire that is you're left with and you're going, oh no, where does this go? Keep in mind, process of elimination. The C, the common on the motor, goes to the C on your dual run capacitor. And again, we know this because the capacitance symbol is between that wire and the start wire up here, which branches off of our common. That C wire has a jumper that goes over to the contactor. We know that the run cannot be on the same side of the contactor. You can't put those two on there. It's going to cause a problem with your motor. This wire that's off by itself in our diagram, again, has to be by itself on your contactor. Just keep in mind the most important thing is that since both legs of your motor need a total of 240 volts to kick the motor on, we have to have our C jumped over to power, and we have to have our R connected on the other leg of the contactor. So common sense, right? We know in line is our capacitor, which once is energized from the contactor at 240, it boosts, it gets that higher voltage, it kicks everything on. It's higher than 240 volts once it gets charged. So always make sure to exercise caution when putting in your new motor. Make sure your disconnect box is pulled. Make sure that if you want to be extra careful, you can turn off your indoor panel and just make sure there's no power going out there. Always use a rubberized screwdriver, something that's non-conductive on the handle but metal on the tip. Touch it on your capacitor and that should discharge it if it's holding a charge at all. So remember when you're putting in your new fan motor that wire colors do not mean anything. Now, unfortunately, if you don't have a wiring diagram on your fan motor, there is a way to figure out what your common, your start, and your run is, and I can show you how to do that. We've actually done that in other videos. But for now, on the wiring diagram, we know what these are and what they mean and where they go. It's always more simple on a OEM motor. But as I showed you before, a universal motor is simple to read. It's just understanding what all that mumbo jumbo is on there. So to compare, once we know what these mean on here, we can now have confidence to compare it to our universal wiring diagram we went over, right? The brown and white stripe on a universal motor, and again, don't focus on colors. When it gets to some universal motors, they do actually have two solid browns, and I have even seen two purples before. So just keep that in mind when looking at the wiring diagram. Again, we know the one that branches off here and the caps coming off of it, the symbol for capacitance is here. So if you're using a 3-wire setup with your dual run capacitor, with our 3 poles here, and obviously one will be C, one will be fan, and one will be Herm. We know that the start, no matter what color that is going to go over to our fan, just like our OEM motor. Our black is going to have that symbol between these two, line. And again, these wiring diagrams can look different, you guys. This could be moved down here. I have seen that before. Between all of this, reversing leads here. And remember, we don't pay attention to that for right now. And an easy way to deal with reversing leads is to just plug everything up, get your fan blade on there, and if the air is not coming out of your unit, then you know it's not going the correct rotation, and you're simply going to swap these wires. So instead of going, say, yellow to yellow, you would go yellow to orange. And that's going to reverse the polarity on the motor, and it'll go in the opposite direction. The black and the white in this case are going to be your 120 and 120. Being that this is going to be off by itself, we know that it's going to be on our contactor, and the most common contactor I see are single pole or pole and a half, they call them. So we know our run is going to go by itself on one leg. And then our C, our common, the one that has the brown branched off of it with its capacitance, or whatever color yours is, that one is going to go over to the C on our capacitor. So again, just like your OEM, 120, 120. And then here is our start. This one goes over to the fan, and that is your compressor wire. So if you have no idea which one of these is your start winding, or if you're the unfortunate victim of having two solid wires, what you can do is test with your meter the continuity on the motor, and that will tell you which one of these will be your start winding, because they are on different windings in the motor. Because this wire is the same as this wire, obviously if you're touching your meter between these two, what's going to happen? It's going to have a very low resistance because it's the same winding. So now that we know if we're touching this one to whichever one of those wires it has two of, if it has a low resistance, then you know for your 3-wire setup on your dual run capacitor, if it has low resistance, boop, boop, you don't use that wire. Cap it off, and for the love of Pete, zip tie that thing out of the way. I have seen 2 fan motors come in this year, but they didn't zip tie this up, and inevitably their fan blade hit it. So please zip tie. Be friendly to your motor. Okay, so since we have that knowledge, we know that this is the same winding as this one. Process of elimination, right? Then you know if you touch this wire and your common wire and you have a higher resistance, you know that is the one that goes on your fan because it's not the same winding. So now that you're armed with that knowledge, you know which one of these would be the correct one to use on your dual run capacitor. Again, zip tie these wires out of the way because more often than not, they do not fit in those tubes, whether yours is conduit or ream has metal. Usually what I do, because I do not like seeing wires tied up on the grill, personally, I think it looks kind of tacky. And also, I am paranoid about wires, so me personally, I like to zip tie these up against the tube. So just make sure you get the wires you're not using on your 3-wire setup out of the way. Now that we've thoroughly gone over this and we can understand and we have that knowledge, okay, Crystal, well, what do we do if we have a little small fan capacitor? Well, we're actually going to use both of these at that point. So here's what we're going to do. We're going to have these right here. We're going to have our reversing leads, whatever color those might be. This is, again, just example colors. Plugs that go down here. We've got these that go down here. Little boxy boys. Brown and white stripe. Okay. Most common, again, you can have 2 solid browns. Well, these 2 wires are conveniently placed here specifically for technicians to use that little small capacitor with 2 poles here. With these smaller fan caps, since there's only 2 poles, there's no polarity on that. What do I mean by that? I mean, it's okay if you can put this wire here and this wire here, or you can swap it. You could put this wire here or this wire here. meaning it doesn't matter. So I have some worried homeowners sometimes that ask that, and no, you don't have to worry. That's only on a dual run. A dual run capacitor, you have 3 poles and it very much matters. Now, when you get this small capacitor that does not replace your larger dual run, okay? A little cruddy guy here, but you get the point. It doesn't replace this. What this translates to is you're no longer going to use your solid brown, your 1 wire on the fan terminal. This is going here, and it's replacing the start from your large dual capacitor. Now that we know, we don't put that wire here. We just take that wire off, okay? Leave the other wires here. This, should be C, this should be Herm. Your compressor still needs power. So that compressor wire needs to stay on there, and that power wire that's jumping over to the contactor needs that power. In order to make this super simple, because there's a number of ways you can do this, put your wire, and again, we're just using placeholder colors here. We know line and line. Well, keep whatever color this was before, keep that where it was before. Keep your other line on which side was it again? The opposite side of where your jumper wire comes off your C. So then that wire goes back to the other side of the contactor. Now, again, there is another way to wire this. And then we're going to take these two, which is power, to the contactor, both of them, straight to the contactor. So we know, now that we have our knowledge, one side needs to be on the contactor here, and the other one needs to be on the opposite leg. All right, guys, thank you so much for joining us today. I hope that you have learned quite a bit. And again, if you have any questions, just leave them in the comments below. And give us a like and subscribe so we can continue to make these for you. Have a wonderful rest of your week, and thank you for joining us. Bye, guys.